Welcome everybody to West Explains Best. Today we're going to be doing section 8.2, which is the quadratic formula. So let's go ahead and get started. So it says for ax squared plus bx plus c, that's any quadratic equation, and it's set equal to 0. We can find the value of x by using this. Now, this is in cases where you can't factor something. Okay, normally you can factor something like this, x minus 2. If you can't factor it, that means that there's decimals or irrational numbers for answers, and that's where the quadratic formula comes in handy. It's able to compute any type of situation. It could be integers, it could be rational numbers, irrational numbers for x. So that's what's pretty useful about the quadratic formula. Now, let's just go over a couple things. You've probably seen this before, but just in case you haven't, A is going to be always, A is always going to be the coefficient of x squared. So whatever the x squared or the n squared or m squared, whatever it is, A is that coefficient, and it gets plugged into these locations. Then we have B. B is the coefficient of the x term, the middle term, and it goes in several spots. Now, you'll notice something that I did that's not typically written in books. I put b in parentheses and the negative outside of it. That's because often you'll have something like this. You'll have x squared minus 2x plus 3, something like this. And then b ends up becoming negative 2. So then what you do is you plug in negative 2, and then you make that negative. A lot of times, because they see my students see negative b, because the 2 is already negative, they just leave it alone, but that's not the case. You need to make it the opposite sign. So if b is negative 2, it ends up becoming positive 2 by the time you're done, and then plus or minus all of this. Okay, so it's very important that you make sure to make the b negative no matter what value it is. If it's negative, it becomes positive. If it's positive, then it becomes negative. And then we have b squared minus 4ac over 2a, and then this is the only c value right here. So here we have a c value. Make sure you guys plug that in, but otherwise it's just b and a mostly. Okay, so there's your b's, and you're good to go. Now let's apply it. It's really, it's not a very complicated procedure. It's just a matter of keeping track of all your variables and making sure you're writing everything down. So your step 1 is find values for A, B, and C. That's the first step. We want to find what does A equal, what does B equal, and what does C equal. Because once we determine that accurately, then we're good to go. We can get everything else figured out, and it's pretty easy. The other thing is we need to make sure before we figure out A, B, and C that it's equal to 0. If it's not equal to 0, you're going to end up with some funky numbers, and it's going to be wrong. So make sure it's equal to 0. In this case, it is, okay? So we can go ahead and figure out what A is. A is 6. B is going to be negative 5. Careful, there's a negative sign there. That's something to watch out for. And then we have C is equal to 4. I'm just going to copy and paste this, the quadratic formula. Okay, so I'm going to copy and paste this down here, and I'm going to plug in my values. Okay, so instead of A, I'm going to write 6. I'm going to put it in parentheses just so you see that we're multiplying by 6. So 6. Instead of C, I'm going to write 4. I'm going to put that in parentheses too. And instead of writing B, I am going to write negative 5. Okay, also important to know that you should be putting this in parentheses here. I should have put that up like this. Okay, because if it's negative, you're going to square the negative and it becomes positive. So it's not like we would square the 5 first, 25, and then make it negative. We would square the negative 5. Okay, that's another important distinction. Now we're just going to go ahead and simplify from here. So we have equals negative 5, minus negative 5 becomes positive 5, plus or minus the square root of 25 minus 4 times 6 times 4. Well, that's the same thing as 16 times 4, which is 64. Oh, no, I'm sorry. 16 times 6. I wrote that down wrong. 96. So we have minus 96 all over 2 times 6, which is 12. Now, this is where it gets tricky. It's not so much complicated as it is tedious. It requires a lot of steps. So I'm going to go ahead and condense this just a little bit, make this line a little straighter. I don't know why it didn't lock and load. Okay, here we go. Lock, load. There we go. Okay, so we have 5 plus or minus the square root of 25 minus 96, negative 71. And then we have over 12. Okay, let's continue. So we have 5 plus or minus. Okay, so what's something you notice? Well, we notice that this is negative inside the radical. So we can split this up into 2 radicals, which is like this, all over 12. So it becomes 5 plus or minus I radical 71. Now we need to make sure 71 isn't divisible by like 13, 17. It's not divisible by 3 because the sum of 7 and 1 is 8, and that's not divisible by 3. That's a little trick I learned. I can't remember. I think it was my 6th grade teacher that taught me that. So now I'm just checking some of the other prime numbers. It's not 7. Maybe 19. 71 divided by 19. 71 divided by 23. 71 divided by 29. Okay, I think it is not. I think that's a prime number. So we're going to call that good. We have the I outside the parentheses, which is what we wanted, and then it's over 12. There we go. Now, as you can see, this is not something we wouldn't have been able to put in parentheses and actually put something in for x and put into parentheses into binomial form. It would have been impossible because clearly we got imaginary numbers, and it's really complex and it's a fraction. So that's why the quadratic formula is useful, because you can figure out values of x no matter what the case. Okay, so we're going to go ahead and proceed to the next one. Again, it's the same step, but the first thing you'll notice is these are not equal to 0. So I'm going to move both of these over. I'm going to subtract 8x from both sides, and I'm going to add 1 to both sides. So I get 4x squared minus 8x plus 1 equals 0. It's really important that you make sure you get everything to one side. Otherwise, you're going to accidentally put b is positive 8 and not negative 8. So we have a equals 4. We have b equals negative 8. And we have c equals negative 1. Now we're just going to go ahead. Again, we're going to plug in our formula, quadratic formula, all our values. So instead of a, we're going to write 4 in parentheses. This might be a good time to fast forward. So if you know how to do this and you don't want to listen to me talk, go ahead and fast forward this part until I'm done. But otherwise, I'll just keep talking to myself, I suppose. I'm just plugging in negative 1 here. Negative 8 is going to be in instead of b, so we have negative 8, negative 8, negative 8, negative 8. Also known as the snowman. That's 8, by the way. Okay. So here we go. Now I'm going to simplify. I'm in the simplify stage. So we have x equals negative 8, negative a negative 8. Okay, you distribute the negative sign, it becomes positive 8. Plus or minus the square root of, this becomes 64. Minus, okay, and notice how this is something you always want to keep in mind. Anytime you have 2 minus signs inside the second part, it's going to be ending up positive. So you have positive 16 there. 4 times 4 times negative 1 is negative 16. Subtracting a negative 16 is the same thing as adding 16. So this is all over 8. Okay, so we're going to add 64 plus 16, and we get 80. So x equals 8 plus or minus the square root of 80 over 8. Now, what we need to do here is we need to simplify radical 80. That's 240, 220, 210, 25. So we have 1 2 come out, another 2 come out, and a 5 stays home. So this is equal to 2 times 2, radical 5, 4 radical 5. So I'm going to rewrite it again. X equals 8 plus or minus 4 radical 5 over 8. I can simplify this because we see that everything is divisible by 8 or 4. So we're going to change this to x equals 2 plus or minus radical 5 over 2. And that's our final answer. Notice here that we have 2 answers for a lot of these problems. So this one had 2 answers. This one had two answers. Where do you see the two answers? Well, in the plus or minus. That means that 5 plus I squared is 71 over 12 is one answer, and 5 minus I squared is 71 over 12 is another answer. Same thing for this, 2 plus radical 5 over 2, and then 2 minus radical 5 over 2. Those are two different answers. Okay, so we're going to talk about the discriminant briefly. This is more useful for graphing, but it's also useful to figure out without solving completely what kind of solutions you're going to get for x when you solve for it. So this right here is known as the discriminant. Okay, discriminant. Whoops, I misspelled it already. It's written right there, discriminant. This essentially distinguishes the number and type of solutions. Okay. Now, what do we know from that? Well, in this example, we noticed that when we had a negative underneath the radical, we had imaginary or complex solutions. We noticed that when we had this scenario right here, where it was positive, that we had two solutions again. So we're going to go through this table and just kind of talk about the different scenarios and what to look for when you're dealing with the discriminant. So if the discriminant is b squared minus 4ac. This by itself is the discriminant. So if we just take whatever our b value is, square it, minus 4 times a times c, we can figure out a lot of information. So the first, if it's positive in a perfect square. So after you solve this, if it's positive and a perfect square, what does that mean? Well, it means you're going to have two solutions, and they're going to be rational. Two rational solutions. Okay? So that's one thing you'll know. That means that there's not going to be a radical sign left over. What if it's positive, but it's not a perfect square? We're going to have two solutions, but they're going to be irrational. We're still going to have a radical sign. So two irrational solutions. What if we get a radical and it's 0? If it's a radical and it's 0, that means we are only going to get one solution. Why is that? Well, because we have b plus or minus the square root, if we get 0, that just means we're going to have b plus or minus 0. That means we're going to only have b in the top and then 2a in the bottom. That's one answer. One solution. And if we have a negative inside the radical, that means we're going to have two complex solutions. Okay, so this little chart is kind of a handy way of remembering what types of solutions we're going to have in certain scenarios. So find the discriminant used to determine the number and type of solutions. First thing you'll notice, this 5 is not on the correct side, so we need to subtract that. 3x squared minus 4x minus 5 equals 0. We need to find our a, that's 3. We need to find our b, that's negative 4. We need to find our c, that's negative 5. Now, what we're going to do is we're going to do b squared minus 4ac, that's our discriminant. So we're going to do negative 4 squared minus 4 times 3 times negative 5. We get 16 minus, now it's a negative, negative, there's two negative signs here. So that means we're going to end up with a positive. What is it going to be a positive of? It's going to be 15 times 4, which is 60. So that gives us 76. Now, is 76 a perfect square? It is not. Because it's not a perfect square, we know we're down to this one or this one. Okay? So which of these is it? It's positive but not perfect square. So we are going to have two irrational solutions. So that's a quick way of kind of identifying what this graph is going to look like, what this quadratic equation is going to look like, what's behavior is going to be. So that's why the discriminant is a little bit useful. It's more important when you get into graphing, but you'll get to that later. All right, that's all I got today for quadratic formula. Hope you found this useful, and I'll see you next time on Wes Explains Best. Take care.